Let's welcome Dr. James Nardi, research scientist in entomology, School of Integrated Biology, University of Illinois, Urbana, Illinois.
Welcome to the world beneath our feet and the creatures that call it home. Rather than being just dirt and an inert matrix into which pesticides and synthetic fertilizers are poured, soil is actually teeming with countless creatures. Healthy soil represents a good marriage of the organic biological world and the inorganic mineral world. So who are the creatures that make up this underground world, and what are their roles, and how are they interconnected? In a soil that has been treated with respect and not like dirt, the creatures can be systematically arranged in the order of their numbers and their sizes. What this pyramid shows is the approximate numbers of different groups of organisms in a small patch of earth measuring 1 square meter and 6 inches deep. If the layers of this pyramid were actually drawn to scale, the bottom layer, indicated by the yellow arrow representing 10 trillion bacteria and fungi, would be 100 million times the size of the mite layer, indicated by the green arrow, representing 100,000 individuals. And the mite layer, in turn, would be 100,000 times the vertebrate layer, indicated by the red arrow at the very top of the pyramid. This pyramid of numbers includes creatures from all the major groups of organisms, including many that are found only in the soil. With this introduction to the diversity and abundance of soil life, we can ask, how are all of us reliant on this world beneath our feet? There are two things that all creatures need: energy and nutrients. Take these two prairie plants, for example. For every pound of vegetation above ground, capturing the energy of the sun, there are 3 pounds of vegetation below ground taking up nutrients from the soil. But these nutrients must first be made available to plants by organisms of the soil, known as the decomposers. As shown in this food web with the green arrows, everything and everyone in nature, the plants, the plant eaters, the meat eaters, the decomposers, eventually end up being recycled by the decomposers to nourish each generation of creatures. Everyone feeds the decomposers, and the decomposers in turn ultimately feed everyone the nutrients that they recycle. The importance of the soil's decomposers in providing nutrients for life above ground is well conveyed by a quote from Jeff Lowenfeld's book, Teeming with Microbes. No one ever fertilized an old growth forest. What else is nature telling us? Here is another quote from a 1943 book, The Living Soil by Lady Eve Balfour. Under natural conditions, the remains of plants and animals are continually converted by decomposers into humus, and the fertility of the soil is permanently maintained. So who are these decomposers, and how do they accomplish their monumental task of maintaining soil fertility, not only by recycling mineral nutrients, but also by generating this material known as humus? In this image, taken with the scanning electron microscope, we can see the bacteria and fungi on a decaying leaf. These bacteria and fungi secrete enzymes to digest the leaf. The bacteria have been artificially colored to be more conspicuous. The fungi and actinomycete filaments have been marked with yellow arrows. Larger decomposers also assist in the recycling by chewing the plant remains into smaller pieces and thus increasing the surface area on which the bacteria and fungi can work. Recycling is certainly a community effort. The most abundant of these decomposers, the mites and springtails shown here, the mite population in a square meter of soil is approximately 100,000 individuals, while the springtail population is around 50,000 individuals. But in addition to all the mites and springtails chomping away on the plant litter, there are thousands of fly larvae, beetles, beetle larvae, millipedes, earthworms, and other decomposers. And these occur at approximately 8,000 individuals per square meter. Here is another scanning electron micrograph showing a mite working among a tangle of fungal filaments on a decaying leaf. And after all the shredding, chomping, ingestion, digestion, and defecation of these countless decomposers, both large and small, mineral nutrients are liberated from the decaying plant remains, and what remains are the hard to digest remnants of the plant litter, and this is the humus. And this is taken from the surface of another decaying leaf. So how does this organic humus interact with the inorganic mineral particles of soil to complete the marriage and maintain soil fertility? What are the special properties of humus? First of all, it's negatively charged, and these negatively charged hold the positively charged soil nutrients such as calcium, magnesium, iron. Humus also acts as a sponge for water, holding about 6 times its weight in water. Humus is rich in organic matter and carbon and helps to remove carbon dioxide from the atmosphere. Humus mixes with mineral particles of soil and aggregates them. What are these mineral particles? Every textbook of soil science points out that every soil has 3 mineral particles whose proportions determine the soil's texture. Large sand particles impart a coarseness to the soil. Intermediate-sized silt particles impart a silky texture, and tiny clay particles impart a stickiness. Some soils are mostly clay, as indicated by the green arrow in this diagram. Some soils are mostly sand, as indicated by the blue. Some soils are mostly silt, as indicated by the red. And soils in which clay, silt, and sand are represented in about equal amounts are loam soils, as indicated by the yellow arrow. This next image gives you an idea of how the sizes of the biological members of the soil that are decomposers compare with the sizes of the large particles of sand and the far smaller particles of silt, indicated by the red arrow, and even smaller particles of clay, indicated by the green arrow. In this next slide, here are 2 soils with identical textures. That is, they have the same proportions of sand, silt, and clay. In the right figure, the humus contributed by the decomposers aggregates the soil particles to give soil a structure that is well drained, well aerated, rich in mineral nutrients, and rich in organic matter or carbon. In short, a soil that is ideal for the health of plants. The soil on the left, by contrast, has little or no humus, has poor structure, is poor in nutrients, and organic matter, is poorly drained, and provides little for plant life. The healthier and happier plants are, the better their immune systems can confront pests. Also, healthy plants emit volatile compounds when challenged by pests. These compounds inform insect predators and parasites that there are plant-feeding insects in the neighborhood. Healthy plants with robust immune systems recruit these predatory and parasitic insects as allies in their confrontations with pests. Soils with minimal tillage, abundant organic matter, and cover crops offer welcoming habitats for creatures that are not only essential decomposers, but predators, parasites, and pollinators. Who needs pesticides when you can attract an abundance of predators and parasitoids? Here are just a few of the many species of predators that inhabit a welcoming soil habitat. Not only are there many individuals of each species, but also there are many species represented. Just as one example, the red arrow indicates rogue beetles. There are 63,000 species of rogue beetles. The green arrows indicate a larval and an adult ground beetle. There are 40,000 species of ground beetles. And finally, the yellow arrow indicates predatory mites. No one knows exactly how many species there are, but there are at least 11,000 species. There are constantly new ones being described. Then there are the parasitic insects. About 10% of all animals, that's 160,000 species, and about 15% of all insects are parasitic insects. Most of these are parasitic wasps, 138,000 species. There are 16,000 species of parasitic flies, and about 5,000 species of parasitic beetles. Many of these parasitic insects are not very particular about their choice of host. Some find over 100 species of host acceptable. However, many specialize in parasitizing certain groups. For example, in this slide, the orange arrow indicates a large palisinid wasp, which specializes in beetle grubs, parasitizing beetle grubs. The blue arrow indicates a braconid wasp. There are at least 17,000 species of these. These specialize in parasitizing aphids. Here are 4 more parasitic insects, 2 flies and 2 wasps. The red arrow indicates a tiny fairy wasp that lives in the soil. And this little creature specializes in parasitizing insect eggs. And the green arrow indicates the robust bristly tachinid wasp. There are about at least 11,000 species of these. And these parasitize caterpillars of all sorts, beetle grubs, you name it. One striking feature of these many insects is that they undergo metamorphosis. They have larval stages as well as adult stages. Therefore, so many of them can contribute to the soil community in one way as a larva and in another way as an adult. These parasitic insects, for example, are parasites only as larvae, but as adult, they're pollinators of plants. These flies, representing over 20,000 species and 4 different families here, are decomposers as larvae in the soil. And when they leave the soil as adults, they're pollinators. These 3 families of flies, representing over 12,000 species of insects, are predators in the soil as larvae, and then they're predators as adults above ground. An undisturbed soil which attracts these predators and parasites and is welcoming to decomposers also is attractive to so many of our native bees. And there are about 25,000 species of these. These bees contribute not only to pollination, but also to improving soil structure by aerating the soil and mixing its organic and mineral components. So I want to conclude by stating, let's cherish all this great diversity of soil. There's an abundance of species and an abundance of individuals in the soil. And let's work in partnership with all these creatures by avoiding the use of pesticides and by continually adding organic matter to the soil to create a welcoming habitat that attracts not only the decomposers, but these predators and parasites and pollinators that are so important in controlling pest insects. There should be no need for pesticides. Thank you.
Let's welcome Dr. Emma Rosi, aquatic ecologist, Carey Institute of Ecosystem Studies, Millbrook, New York.
Hi, my name is Emma Rosi, and I'm a senior scientist at the Carey Institute of Ecosystem Studies. And today I'm going to talk to you about aquatic ecosystem health in the Anthropocene. So as many people now know, we are now in a new geologic era called the Anthropocene. The evidence of human activities on the planet is such that we are leaving what geologists believe is a permanent footprint on the planet, and that they will be able to see long after much of our human activity has gone. So much of the trash that we use, the pollution that we use, is going to be leaving a mark on the planet for a long time into the future. And as a stream ecosystem ecologist, there are basically many things that influence aquatic ecosystems and the Anthropocene. This is a figure from a paper we published a number of years ago that just highlights the many different ways that headwater streams or river stream ecosystems are influenced by human activities. So building cities, widespread agriculture and crop raising of crops, animal husbandry, trash like microplastics and larger plastics, sewage effluent, oil and gas, building dams, invasive species, and then climate change are all going to influence stream ecosystems. They do now and into the future. This is a figure showing a watershed. So the stream is in blue, the light blue area is the watershed. And this is it's sort of taking all of these stresses and thinking about how aquatic ecosystems are really under threat, because in any given watershed, there could be, for example, construction of dams in the headwaters, which alters the flow, the habitat, and the temperature of the ecosystems. There could be agriculture, row crop agriculture that adds nutrients and pesticides into aquatic ecosystems, fundamentally altering the habitat and the quality of the water. And then urban ecosystems contribute pollutants, nutrients. And then on top of all of that, we have alterations in CO2 in the atmosphere, which is leading to global climate change, which influences the amount of flow and the precipitation in a river. So as an ecologist, I'm really interested in trying to understand the ecological condition of these aquatic ecosystems, given these multiple stressors and threats to aquatic ecosystems. So today I just wanted to remind you, or to teach you all about all of these different stressors that are affecting aquatic ecosystems. And I'm going to focus a little bit on the work that I have done as a way to think about the health of aquatic ecosystems in the Anthropocene. So Rachel Carson wrote a book, Silent Spring, in 1962. Arguably, this book is a book that changed the world. Rachel Carson wrote these words that I want to quote to you right now. "The chemicals to which life is asked to make its adjustment are no longer merely the calcium and silica and copper and all of the rest of the minerals washed out of the rocks and carried in rivers to the sea. They are the synthetic creation of man's inventive mind, brewed in his laboratory and having no counterparts in nature." Rachel Carson wrote those words in 1962. She was more right today than she knew. We have so many synthetic chemicals that are entering our aquatic and terrestrial ecosystems, our planet today. It's even more true today than when she wrote those words. This is a publication we published a couple of years ago on the recognized agents of global change are here in the gray and black. So we know that the world is being fundamentally altered by human activities. Things like the increase in availability of nitrogen fertilizer, phosphorus fertilizer, the large increase in the human population, CO2 in the atmosphere, and loss of biodiversity. Of course, the increase in agricultural land. So the world has changed, and we call these agents of global change. So they're basically changes that are happening on a global scale. In this paper, we argued that we should view synthetic chemicals on the same scale as other agents of global change. We should recognize them with their global nature. And we made the case and we said, well, since 1962, which is what these graphs are based on, when Rachel Carson wrote Silent Spring, the number of pesticides, the number of pharmaceuticals, and the use of pesticides, and in the green here is the dollar output, because it's hard to come up with the pounds that are being applied to the world, but the dollar outputs of these have just increased exponentially, and in fact, even greater than some other recognized agents of global change. So we are both producing many, many more of these. We are distributing them around the world, and there are serious ecological consequences of their use. And so we made the case a number of years ago that we should consider synthetic chemicals as agents of global change. Just to give you a sense of just how many chemicals are we producing, it's estimated that over 350,000 chemicals or chemical mixtures are registered. Chemicals all get registered with what's called a CAS number. And basically there's a big database on all the chemicals that are out there. And it's over 350,000. So this is a paper that was just published by Wang et al. In 2020. This does not include about 50,000 confidential compounds for which companies don't release the information, or 70,000 ambiguously described compounds. And then it does not include the breakdown products. So many synthetic chemicals, once they enter the environment, they break down in ways, but they don't necessarily break down into their constituent parts. They break down into some other chemical, which at times are more toxic than the parent compound. The EPA regulates the release of sewage. The EPA regulates the release of some of these chemicals. So pesticides, for example, are regulated. But pharmaceuticals and personal care products, which I'm going to talk about in a moment, are not regulated specifically by the EPA. They are not listed as aquatic contaminants. Pesticides are, trace metals are, but the ones that I'm going to focus on and I have focused my career on are not listed as aquatic contaminants. And although the FDA regulates the safety of drugs, that's safety for human use. It is not safety for the environment necessarily. So I'm going to shift gears and tell you about the work that I have done on pharmaceuticals and personal care products, which are now a part of river ecosystems. And this is a way of thinking about contaminants in rivers. And so I'm going to talk to you about this. I know that this is for a Beyond Pesticides conference. I haven't worked much on pesticides, so I'm going to give you some ways of thinking about how different chemicals can affect aquatic ecosystems. And by using the example of work that I've done on these pharmaceuticals and personal care products. So these compounds, it's kind of a mouthful, pharmaceuticals and personal care products. Sometimes we refer to them as PPCPs. Basically, we group them together because they enter the environment in a similar way. But they're really, really different compounds. So an antibiotic is fundamentally different than an antihistamine. And in fact, two antibiotics might be very different from each other. Antidepressants are really different. Painkillers, this includes things like insect repellents and sunscreens and illicit drugs and cosmetics. So in the US, it's about 1,400 pharmaceuticals, but that does not include cosmetics, over-the-counter medication, fragrances, a whole bunch of other compounds, detergents and things like that. So there are many, many of these compounds, and they have been detected widely in surface waters. I don't have time to tell you all the different pathways that these enter the environment, so I'm just going to give you a quick summary. These compounds are manufactured in facilities, and so if the manufacturing facility is discharging the washing of the equipment, it washes down into aquatic ecosystems. They come into wastewater treatment plants. After we use them in our everyday lives, they get washed down into a wastewater treatment plant, and wastewater treatment plants are not designed to and often don't remove them from effluent. So they enter the system that way. Much of the waste that goes into our wastewater treatment plants is both a liquid and a solid form. The biosolids, so the solid part of the waste, or sewage sludge it used to be called, in much of the US, it's land applied to get rid of it, basically. There's a lot of it, so they land apply it, and that can have pharmaceutical residues. The other thing is, in the US, we have real problems with infrastructure, including our sewage infrastructure. And so it's leaking, and it will cost a great amount of money to repair it. And then we also use pharmaceuticals in agriculture. So especially for animal husbandry, in order to have animals in confined to animal feeding operations, we use about 50% of the antibiotics that are used in the US are used actually for animals. They're not for people. So this is just to give you an idea. Anywhere that there are people in a watershed, there's likely to be pharmaceuticals and personal care products and many other contaminants that we use in our everyday lives. So even in potentially surprising places like the Antarctic Peninsula, where there aren't really people, but there are people. People go there as tourists, and they've been found, a number of these pharmaceuticals have been found in streams in the Antarctic Peninsula because people bring with them their drugs when they, in their waste. Also, in a study that was done a number of years ago by the USGS, found a variety of compounds in the US national parks. So there are tourists in national parks. So quickly, I just want to talk to you about how pharmaceuticals affect river ecosystems. So what are the effects of these? Basically, research in my lab done by a number of graduate students and postdocs, and you can find these publications at my website. Basically, there's a whole lot of ecological effects that these compounds do. They can change the community composition of bacteria. They can alter antibiotic resistance. They can alter ecosystem processes like primary production or respiration or denitrification, nutrient cycling. They can change life histories of aquatic organisms. They can influence the mortality of crayfish, and they can change behavior. And so basically, these synthetic chemicals that we are using in our everyday lives have effects on aquatic organisms and aquatic ecosystems that they enter. And the way we think of them is we think of pharmaceuticals and personal care products as what we call ecological disrupting compounds. These compounds are very different from other contaminants that are viewed as toxic, right? So a number of pesticides or herbicides are used because we know that they kill certain things. Well, pharmaceuticals and personal care products are different in that we take them to do a biological effect that is not mortality. And so we argue that we should think about the concentration, which is much lower, that leads to an ecological disruption rather than the concentration that causes toxicity. However, there is not much research on these different ecological effects. And this is the case for pharmaceuticals and personal care products and many of the synthetic chemicals I was talking about earlier. We just don't know what the effects are on food webs and ecosystem processes. And one last study I want to tell you about is that these pharmaceuticals and personal care products actually move through food webs. This was a study that was done a number of years ago. We collected aquatic insects. We found over 69 different pharmaceuticals in the aquatic insects. And then we actually found those pharmaceuticals in spiders that eat the emerged aquatic insects. And we did a model, and we found that platypus, this was work that we did in Australia, when they eat aquatic insects in the streams, they would get nearly 60% of a human dose of antidepressants just from eating the food that they typically do. So contaminants in rivers, it's a work in progress. There is so much more that we don't understand about the effects of these hundreds of thousands of synthetic chemicals that we are using in our lives. We don't know what the effects are on aquatic ecosystems. But one point I want to leave you with is that we need to have a holistic view to understand how these effects of contaminants, such as drugs, pesticides, what the effects they have on aquatic ecosystems, and how, of course, they interact with other stressors like climate change and nutrient pollution and pesticides. All of these things together are multiple stressors affecting aquatic ecosystems. Just one last thing about what you can do. When you have pharmaceuticals or other chemicals in your home, please dispose of them using take-back programs. Do not flush things down the drain that you don't want, so properly dispose of them. And then, of course, we really need to urge our lawmakers to maintain and upgrade our infrastructure, in particular our sewage infrastructure, and to support this kind of research, which is very much needed to understand the effects of these compounds. Thank you so much.
Let's welcome George Kimbrell, Legal Director, Center for Food Safety, Portland, Oregon.
Well, hello, good afternoon. George Kimbrell, the Legal Director for Center for Food Safety, and I want to thank Jay and Beyond Pesticides for having me at the conference. It's nice to be with all of you virtually. For those of you that might not know, the Center for Food Safety is a nationwide nonprofit devoted to protecting farmers and the earth from the harmful impacts of industrial agriculture. We've got about 1 million members across the country, and you can find out more on our website at centerforfoodsafety.org. Today, I'm going to talk through some of our litigation, our pesticide cases that are currently in the courts, and give you updates, cutting edge, rip from the headline updates of where we are on various important cases, and then take you home with some overarching points with regards to the new incoming Biden administration and where we'd like to see pesticide oversight and regulation going forward, taking pieces from those cases. So there's a lot going on. It's been a busy last 4 years in particular in the courts, and a lot of what we do at CFS is try to be the legal eyes and ears of the food movement and address things like the harmful impacts of pesticides on health and on the environment. One of our flagship cases the last 4 years that I've been litigating is the dicamba case. This is a case about Monsanto's Xtandi Max pesticide that is the new over-the-top spraying of genetically engineered cotton and soy that is resistant to not just Roundup, but also dicamba. And it's been a huge issue in American agriculture, very controversial one, because it has caused, among other things, massive off-field volatilization and drift and harm to other farmers' crops across the country, millions of acres, unprecedented amounts, such that we've never seen with any pesticide ever in the history of American agriculture. So it's been a really major issue. We started litigating the case in 2016, and it worked its way through the courts. The first variety from 2016 to 2018, and then the second case from 2018 to 2020. Last summer in June, we received a victorious decision from the Ninth Circuit Court of Appeals. I should say in that case, we're representing a coalition of farmers and conservationists. And our claims had to do with crop damage from dicamba drift, but also Endangered Species Act harm and ecological harm from dicamba drift and runoff. And the panel unanimously sided with us in rescinding EPA's registration of the dicamba pesticides and holding that they were unlawfully approved. And it created several important precedents for all pesticide law as far as what EPA will have to do going forward when it registers pesticides. I think it's fair to say that it's the most important pesticide decision probably in about 10 years as far as creating new aspects of law and kind of breathing new life into the way we regulate pesticides. So I would highlight just a few of those briefly. I would say first, the court's decision requires EPA to really take a hard look at the costs, the actual quantifiable costs to farmers from pesticide drift. In the past, EPA has essentially given a hand wave to those costs and really just focused on the punitive benefits, alleged benefits of approving such a pesticide. But now going forward for dicamba and all other pesticides, it's really going to have to take a look at things like what are going to be the ramifications, financial and otherwise, to farmers and farming communities and farm workers from approving these pesticides, particularly from drift and runoff. The court also struck down the approval because EPA had relied on basically what was an impossible to follow label. A label is really a misnomer when it comes to most modern pesticides. What we're talking about is a website that's 40 pages long for farmers to have to look at and try to follow that, are created in Washington, D.C. and are not realistic and practicable in real world farming conditions. As a lot of the farmers told us in the cases, it's a fairy tale that they can try to follow these. And so predicating an approval on a farmer's ability to follow these directions and then blaming them as Monsanto did after they're not able to and drift occurs, injury occurs off field widespread is not a good way to approve pesticides. And the court said it was unlawful, in fact, and struck it down. And so just to give you an idea of, how onerous those use directions were, some Indiana state scientists studied them and said that there were only 47 hours in the whole month of June where, farmers could spray dicamba lawfully one particular summer 2018. So in any event, I think this reliance on impossible labels makes oversight illusory. And so EPA will have to be grappling with that in the future. There were other holdings. Those were some of the major ones. The other one that I would highlight quickly is just this idea of social impacts. The pesticide law talks about not just financial injuries, but also impacts to communities. And the dicamba controversy tore a hole in the social fabric of pitting farmer against farmer in these agricultural communities. Because you have your neighbor who wants to spray and then it's harming your crops and killing your vegetable crops or your oak trees or whatever it is, because dicamba is a very toxic pesticide that kills pretty much anything that's green unless it's genetically engineered to be resistant to it. So not just corn and soy, but also trees, vegetables, berries, anything like that, grapes. And the court said that EPA had to grapple with those harms and really address them in future approvals. So, that's the dicamba litigation. I would say as an update, 5 months after that decision, right before the presidential election, the Trump administration reapproved dicamba pesticides in late October 2020, pretty much doubling down on that unlawful decision. So we are now back in court challenging that reapproval by the Trump administration and basically arguing that they have failed to correct the legal failings from the prior registration. So we'll keep you updated on how that goes. Okay, so I'd say a few more important cases currently in the courts. One I would highlight would be the glyphosate or Roundup litigation that's currently ongoing. This is a case about the re-registration of glyphosate, the active ingredient in Roundup, and of course, glyphosate being the most prominent pesticide in the history of mankind, but currently in modern times as well, mostly because of the widespread commercialization of Roundup Ready crop systems in the mid-90s and in the last several decades. And it's caused dramatic harm, ecological harm, which is very well established, including dramatically increasing the overall pesticide use into our environment, nearly causing the extinction of monarch butterflies, who are now going to be listed on the Endangered Species Act, among other things. And then, of course, human health harms. And this is cancer risks to farmers and farm workers and others from skin exposure, from inhalation. Just this morning, there was a decision from the Ninth Circuit in one of those cases, the Hardeman case, about cancer, where the Ninth Circuit upheld a district court award of $70 million to Mr. Hardeman for the cancer verdict that the jury gave him in that case. So, another piece of the Roundup reckoning that is currently ongoing in the court system, both on the human health as well as the ecological side. We filed a brief in that case in support of Mr. Hardeman. And it's also related to our more broadly registration litigation that is currently ongoing, where we allege, among other things, cancer risks to farm workers and farmers from the use of Roundup. And so now I think, the new administration really needs to grapple with this reckoning that's happening with Roundup. And we have the case presented there in court, arguing that the registration should be overturned on ecological grounds, Endangered Species Act grounds, and on health risk grounds. So that's one to follow. We filed our opening brief in that in December, and next week EPA and Monsanto will be filing their papers, and we'll go ahead. There'll be probably an argument later this year in court on that case. Anything else on glyphosate? Yeah, no, I think the other two cases I would highlight. One on neonicotinoid pesticides. We have a case right now that's ongoing. That's a very important case, the sulfoxaflor case. So as most of you I'm sure know, neonics are the major driver, among other things, of colony collapse disorder and harm to bees. The vast majority of these pesticides are not sprayed, but are used as treated articles or on coated seeds. And so it's a particularly harmful killer of bees because of the systemic aspect of these seed coatings, where the pesticide is expressed not just when it's sprayed on a particular part of the plant, but as the plant grows through its nectar, pollen, stem, all the different aspects. So when the insects interact with the plant as it grows, they're going to be interacting with the pesticide many more ways. It's also used as a prophylactic on these seeds. And so a lot of it sloughs off and goes out into the environment, where it also has caused dramatic harm. So we've had a number of cases on neonics. One case for about 8 years running on clothianidin and thiamethoxam that we litigated from 2012 to 2018 that came to successful conclusion, requiring EPA to do further Endangered Species Act analysis and pulling 12 of those pesticides off the market in 2018. And then our most recent one is on this sulfoxaflor, pesticide, which is another neonic that EPA has approved. And currently, the status of that case, again, in progress, is that EPA has admitted that they are in violation of the law under the Endangered Species Act, but they've argued to the court that they want to keep the pesticide on the market nonetheless. And so we have successfully to this point disputed that and said no, they need to rescind the registration, like the dicamba registration. And so our reply brief is due at the beginning of June on that, and then we'll have an argument in court. I think in September is when the court has scheduled it now. So we'll await a decision on that one, but that's one of the current big neonic cases that's out there. I would also highlight two outstanding kind of big picture legal petitions that we have on fixing pesticide regulation more broadly in front of the Biden administration that have to do with this topic in particular and more generally. One is what we call the coated seed petition, which is a 2017 legal blueprint and impetus that we lodged that basically says, look, these coated seeds are getting a pass. They need to be regulated and not go through this kind of loophole that they currently go through under FIFRA. And so one of the things I would say that folks can do is pressure the Biden administration to simply grant that petition and make the changes that it asks for. Another legal petition we have pending in front of the Biden administration, where similarly, I think our community can speak loudly and have an effect with the new administration, is called the whole formula petition. And that petition basically says, look, you can't just regulate the active ingredient of these pesticides. You need to regulate all of them, including the whole toxic soup, including all the inerts, quote unquote, the surfactants, all the rest of it that's in the formulations. Because right now, most of EPA's testing focuses only on the active ingredient and has blinders on to the rest of the toxicity in the products. And so both of those things would be programmatic improvements at EPA to the way they regulate pesticides. And there are ways that our community can speak loudly and influence things at the agency level. We also, I would say very quickly, have a current case ongoing on the re-registration of atrazine, which after glyphosate is the second most used pesticide in America right now. So, I mean, it's fair to say that on the way out the door, the Trump administration approved every pesticide they could as quickly as they could. And so right now, there's still a lot of litigation ongoing to try to, hold the wall on that and stop the bleeding on that. But with the Biden administration, there's also a chance to shift the consciousness and to really pressure them, if we speak loudly as a food community and movement, to do better. Now, I think it's fair to say that the Pesticide Office of Regulation under both Republican administrations and Democratic ones has been rotten to the core and has been controlled by regulated entities, namely the pesticide companies. So really, we need a sea change at the agency and a cleaning house at the agency, and to make sure that they make decisions based on sound science and proper lawful analysis and approval if they're going to approve a pesticide, including looking at its costs. Now, our recent decisions have helped to try to breathe some life back into that pesticide law. The dicamba case, some of the other cases I didn't have time to mention, but there's been a wave of them over the last 5-6 years that have really given it more teeth. But we need way more than that. We need a change of political will at the agency. And ideally, we need new legislation from Congress. And there is a bill, a 2020 bill, that FIFRA amendments, the Protect America's Children from Toxic Pesticides Act, that you can also support. Doesn't do everything that we need, but it is a dramatic improvement to the current law. So that's another marker that our community can focus its energies on as far as trying to improve things. So I would close by just saying that it's our hope that EPA catches the drift, pun intended, from our recent cases and really shapes up. But if it doesn't, we'll continue to do what we do, which is hold them accountable as a third-party watchdog and take them to court on behalf of other nonprofits, farmers, and other impacted, disadvantaged communities. So thank you all for all the good work that you do, and it's nice to be with you here at this conference, as always, to speak at the Beyond Pesticides Forum. So thanks again for having me.
Let's welcome Amy Lewis, Vice President of Policy and Communications, Wild Foundation, Boulder, Colorado.
I was fresh out of an environmental policy PhD program when I came to my current career on an international team committed to protecting half of Earth's land and seas. You heard me right, half. I'll get to that in just a minute. I left academia, where I was researching the relationship between social movements, pesticide policy, and neonic usage in North America, because I believe the challenges humanity now confronts are clear and present dangers. The irreversibility of their catastrophic impacts imminent. Acting on my beliefs, which I still hold, by the way, I exited the ivory tower to apply the insights and knowledge I had gathered while a scholar of international social movements. And I'm happy to report that if nothing else, I have learned far more as an active agent on the front lines of global public perception of environmental issues than I probably ever would have learned as a researcher on the sidelines. I am pleased today to be here at the Beyond Pesticides conference to share with you what I consider to be the most important lesson I have learned. But before I do that, a little bit more about what I do and why I do it. One of the founders of my organization, the Wild Foundation, was a man named Ian Player, a South African game ranger who, along with his mentor, a Zulu elder named Makubo Ntambela, was the first to remove and save a large mammal from the IUCN endangered species list, the southern white rhino. Together, these two men accomplished this in apartheid South Africa in the context of incredible obstacles, not the least of which being that their friendship, let alone the nature of their partnership, was considered a crime. Now, Ian was fond of describing conservation in military terms, and he would frequently say that conservation is a rearguard action, meaning that it was something done in retreat and defensively. And if you look at conservation today, even though we have numerous success stories from around the world, it is in fact primarily still a rearguard action. We defend, if we are lucky, postage stamp sized areas on a vast globe, the last bastions of healthy biodiversity, even as the interconnected planetary life support system, forests and oceans and peat bogs and prairies, vanish before our eyes. And so Ian, even after saving the southern white rhino from the very brink of extinction, came to the conclusion that, yeah, he and Makubu could run around Africa, saving lots of different species and winning a lot of battles, all while ultimately losing the war. Because the war isn't just for one species or one space, it's a war for the entire web of life and our relationship within it. It was Ian's partner, Makubu, who proposed a different approach to conservation, one that was simultaneously more human-centered and more offensive at the same time. Makubu urged Ian to call for a global indaba. In Zulu, an indaba is a time in which the tribes gather for the purposes of reaffirming shared values, developing a consensus, and agreeing on coordinated actions. In essence, Makubu was proposing taking conservation out of the field and placing it where all environmental problems originate, society. And he did so based on the ancient indigenous belief that values by themselves are not enough. Values require an active community of participants to manifest in the world. This is how the Wild Foundation started and why for the last 50 years, we have been building programs, communities, and leadership that will help drive value-driven action for transformative change. And for the next 10 critical years, Wild has dedicated its resources to building awareness and support for the need to protect half of Earth's land and seas in time to stabilize the climate emergency and halt mass extinction. Foundational to achieving this necessary and ambitious goal is the 100% recognition of Indigenous rights to their lands, because Indigenous nations, although consisting of only 5% of the world's population, steward close to 40% of our remaining wildlands and wild seas, the living life support system of our planet, and up to 80% of our remaining biodiversity. As you can see, the Wild Foundation, at least, is no longer on the defensive. So why do we feel compelled to take on this enormous goal? Well, first, it's the scientific consensus. I'm sure many of you have read the book Half Earth by E.O. Wilson. That was published in 2016 and really helped advance the notion in the public consciousness of protecting half. But that idea didn't start then. It's been around for a long time. In the 1990s, Reed Noss made the first call to protect half of Earth's land and seas. And in fact, back in the early 1970s, the ODMs were first publishing research that demonstrated that when more than approximately half of an ecosystem is degraded, now it varies by landscape, some ecosystems only need 40%, while others like rainforests need 80%. But if approximately half is degraded, functionality drops precipitously. This is called a tipping point. And it means that if you depended on a landscape to, say, store carbon or produce oxygen or purify water or produce rainfall or any number of irreplaceable services nature provides us for free, you'll only have 10% or 5 or 4% of that functionality once you cross that half threshold. And even before the ODM's research, Indigenous leaders and traditional scientists were calling for the same. Now, I know all of you are familiar with the life-sustaining benefits of pollinators and that pollinators need habitat, lots of it and free from pesticides to thrive. So I'm going to take a different approach here. How could protecting nature and biodiversity on a planetary scale help with something like the climate emergency? Well, for starters, halting deforestation, literally putting an end to it, will reduce annual carbon emissions conservatively by 15%. That's right. Just by stopping doing one thing, we can take a significant bite out of carbon emissions. And if we were to restore about 0.5% of Earth's surface to wildlands, that's 350 million hectares, we could draw down 1/3 of the excess carbon in the atmosphere. Given that we know how to feed and house the planet with the available lands under cultivation, That's a fact. And we know how to restore many of our degraded wildlands. In fact, a lot of people would probably have a lot of fun doing so. And we know that we urgently need to do these things to ensure the survival of our civilization. The only mystery that remains is, why aren't we doing it? Why aren't we applying our collective knowledge? Why aren't we acting on what we know? We have a narrow window of opportunity to halt the biggest catastrophe our species has ever witnessed. Why aren't we taking action now? And here is the fundamental misperception about what is needed. Because of my role at the nexus of communications, community organizing, and social movement building, I am often mistaken for a science communicator. And while science is important and the basis of my own beliefs, what the science says about science is that science alone does not mobilize action. It does not call communities together to reaffirm their values and make collective decisions, some of which might require a shift in how we utilize the natural world. Science doesn't tell us who we are as a community or what that even means. This is a commonly accepted fact in social movement research. It is less well known, however, in the environmental movement, and the primary reason I feel called to actively serve in the movement to build support for protecting nature. More importantly, science can't, by its nature, teach us what it is we respect about ourselves and each other. And respect is key. So if science can't mobilize action, what can? In December of 2019, while at the very disappointing climate COP in Madrid, Spain, an elder of the Sioux Nation addressed me and asked me a very pointed question, and by doing so, addressed the culture I represent. Who raised you? He asked. Did they not teach you how to respect yourself? I might have taken such a question personally if I had not had the privilege of spending a lot of time with other Indigenous leaders from around the world. People like Ilarion Merkuliev of the Ungana people in the Bering Sea, Julie Kajun of the Salish Kootenai in the United States and Canada, and Chief Tashka Yawanawa of the Yawanawa in the Amazon. Each and every one of them has shared with me in his or her own way a belief that is central to their cultures and life ways: the primal importance of respect. You see, many Indigenous people believe that we, each and every one of us, are all gifted with a vision to see the wholeness and interconnectedness of the world, to see that all of creation is fragments of our other selves. Should we awaken to this vision, we will gain respect, the prime motivator and prerequisite for all other values like wisdom, honesty, strength, courage, humility, and kindness. Respect comes first. When we destroy the natural world and poison what remains, we demonstrate that not only do we not respect the awesome power of nature, we don't even respect our interconnectedness to the web of life and our equally awesome potential to live well and live in harmony with it. When we amputate nature's parts, we amputate parts of ourselves. When we poison nature, we poison ourselves. It is a lack of respect that carves the gulf between what we know needs to be done and actually making the effort to do it. Respect is the missing ingredient in our actions. Cultivating respect for each other and nature involves a different approach to conservation and different strategies and tactics than the ones we currently prioritize in the environmental movement writ large, and certainly within conservation. It means balancing scientific research with community organizing, shifting communications away from educational outreach and into storytelling, with an emphasis on the audience as the hero, and approaching others with open hearts and open ears, and not bombarding them with what we want them to hear first. When we listen to what troubles others, we know better how we can offer them something in return for their agreement. It is my firm belief that the survival of our civilization as we know it now depends upon inculcating a vast respect and appreciation for what came before us, what exists alongside us without our effort, and what will come after we are gone: wild nature. It also depends on our ability to penetrate the illusions of independence and to recognize that we aren't just depending on wild things, we are wild things, so that we understand that when we disregard the wilder places, from the most modest meadow to the greatest, most majestic forest, we in fact disregard our very selves. This autumn, the world convenes in two different meetings, the IUCN World Conservation Congress and the United Nations Convention on Biological Diversity. Both of these meetings will convene official government delegations from around the world to debate how much nature we need to survive and set new spatial targets. The dominant proposal is for 30%, and it is being proposed based on questions of political feasibility. But if we include Indigenous lands, and we should, we are already only a few percentage points away from 30%, and the science is clear. We need half. In the next 25 years, the world is on track to double the amount of urban square footage and add a staggering 25 million kilometers of road to Earth's surface. That's enough road to encircle Earth 600 times. One of my questions is, when is it more feasible to protect nature? When it still exists as it does now, although diminished, or after it has already been destroyed and needs to be restored on an unimaginable scale? But my other, more important question is it ever too soon or too politically unfeasible to act with greater respect for ourselves? And if the answer to that question is yes, does the problem lie with respect or with our politics? It is my sincere belief that everyone attending the Beyond Pesticides conference is living with a great respect for themselves and the natural world, and are shining examples for their own communities. If you would like to have a seat at the table at the IUCN and the United Nations later this year, I ask that you add your name to the petition we will be taking to world leaders, the Global Deal for Nature, that calls for protecting half of Earth's land and seas so that we can live with greater respect for all life. You can find the petition at theglobaldealfornature.org. I also ask that we move forward as a movement for a more respectful relationship with the planetary web of life, and that we consider how we can employ softer skills and tactics that will paradoxically take the positions we champion out of the defensive and place our movement on the offensive. Respect isn't just a value, it's a lifestyle strategy. And our way of life now depends upon the restoration of our respect for the wider world, each other, and ourselves.